Hello everybody, I am Paul Ducklin from Sophos Naked Security, back for another week's Naked Security live talk. As you can see, today's topic is Jargonbuster, bugs, vulns, exploits and 0 days. And the idea is we're going to take some terminology, bugs, vulns, exploits, etc., that you'll often hear in security reports that are just used often very loosely, and there's an assumption that everyone understands what they mean, and yet you rarely hear them explained in plain English. So that is my goal today. And the reason I thought that today was a good day for that is because today I published an article. Whoops, I've messed that up. Let me just show you what it looks like. So this is an article we published today on nakedsecurity.sophos.com if you want to have a look. Chrome 0-day browser bug fixed. There I am using jargon right there in the headline. Patch now. That's as much as we could fit in the space of the headline. And the simple story there is that the Google Chrome browser, the most widely used browser in the world and the basis for many other browsers, it's that the Chromium source is also used by lots of other browsers. Google discovered that there was a bug in there, and unfortunately when it was reported to them they realized that the crooks were already using this bug in the wild, presumably for bad stuff. It's a bug in the JavaScript engine inside Chromium, so we imagine that if you can be lured to a booby-trapped web page with some booby-trapped JavaScript in it, then just by viewing the page without going through any other clickings and are you sure and do you really want to do this and warning this could be bad, something awful could happen on your computer, for example implanting of malware. And Google, as you probably know, their Project Zero bug hunting team, they're very accomplished, but they're often very loud in talking about bugs in other people's products. In this case it's a bug in their own product, and they've kind of just said there's this bug, you need to patch it, we're not saying anything right now. And the reason for that is not entirely mysterious. It's simply that because the crooks are already using this, the less they say at this point, maybe for a few days, while the early adopters get the patch and while Chrome's automatic updating fetches the patch, the less likely it is that thousands of people go, ooh, let's see what we can do with that. So I understand why they're being quiet, but all they're saying is there's this 0 day, and they're using words like bug, vulnerability, exploit. So I figured let us take this opportunity to go through these three things. So we're going to be looking at bugs, we're going to be looking at vulns or vulnerabilities. Now the jargon term vulns, you'll often see it abbreviated like that. You see I did that on my index card, it was a lot less writing. And we're going to be looking of course at exploits, and we're going to be looking at the flip side of exploits, if you like, which are things called 0 days. You'll also see the word zero abbreviated with the digit 0. You'll see I've put in a half-hearted hyphen in 0 days. It's a very open question in linguistics whether you should hyphenate 0 days or write it as two words. The one thing it seems you can't do is write 0 days yet as one word. Maybe in a couple of years they'll be so well known that will happen. So let's go through what we mean by those things, and you'll see that the choice of those colours was not incidental. The bugs they're on a white index card. I actually wanted green, but then I figured A, green gives the impression I'm giving bugs a green light, which I don't want to, and B, actually I didn't have any green index cards. Vulns are yellow, or let's call it amber in traffic light technology, meaning there's something we need to worry about. And exploits have got, well, they're pink or red there. You imagine if when I get to it saying 0 days, then imagine that bright flashing red, and we'll see why in a minute. So let's get going. A bug, very simply, is, as you probably know, the generic term for something, some kind of flaw in computer software that's not supposed to be there. That sounds like I don't need to say the last bit, because obviously flaws aren't supposed to be there. And loosely speaking, bugs kind of manifest themselves in two ways. There's either something that the program is supposed to do, but it does not, or something that the program is not supposed to do, yet it does. And in fact, many bugs are kind of a little bit of a mixture of those. There are features that are supposed to work one way, but actually misbehave in a way that causes problems or wasted time or mischief, or as we shall see, much worse. So here's an example of what I might mean by a bug, and we'll build on this to see the difference between bugs, vulnerabilities, and exploits as we go along. So I want you to imagine you've got, say, a browser, and when you visited a web page and it's appeared on the screen and it's shoved all its content into the browser, which is provided by the other side, that there's a button you can press that says print this page. And let's say that the expected behavior of the software, when you press that button, is the first thing it will do is, have you got your printer plugged in and is it online? So a little dialog will come up, check that your printer is online. Okay, and then you proceed if the printer's working. And after that, there's supposed to be a second dialog, let's imagine this, that says, are you sure you want to print this page? That stops you printing stuff that you didn't mean to and wasting paper, or just having stuff, for example, in an office, maybe coming out on some remote printer somewhere that you didn't want to. And it also means that because you expect that dialog box to appear, it means that if someone tries to use JavaScript in a web page to print stuff without hoping that it will print without asking you, which would waste your paper, that you'll nevertheless get that dialog. So that sounds like reasonable and expected behavior. And that's how you've got used to using your browser, and it all seems to work fine. Every time you try and print, it says, check that your printer's online. And when it is online, it lets you press OK, and then it says, confirm that you wish to print, OK, and out comes the web page printed on your printer. Great. So a bug might be something like this. Imagine that you go out, you buy a new type of printer, and it requires some slightly different printer driver, and something is that the browser maker didn't think of when that printer was made. Perhaps it doesn't work quite well with that printer, and perhaps when you press the print button, it comes up saying, please check that the printer is online. And you check that it's online, and the bug might be that when inspecting the status of the printer from the operating system, the browser can't tell whether it's online or offline, always assumes that it's offline, and therefore says, check that the printer is online. And you check that it's online, and you press OK, and you never get to the point where you can print. Now that would be a bug. The program is not supposed to behave that way. It's supposed to detect that the printer's online and then ask you if you want to print and proceed. So it's kind of an annoying bug because it means that with that brand of printer, you can't print properly, but you probably wouldn't consider that to be very much of a security risk. And there's probably a workaround. You could say print to a file and then go out and copy the file to the printer. It's a bit of a roundabout way. It takes you a lot longer. It's a little bit of a hassle, but it still means it's not that your printer's broken. It's not that the browser's broken. It's just that the program isn't working quite correctly, and something needs to be changed in the code so it can recognize your printer as well as all the other printers in the world. So that's an example of a bug. It's a misfeature, a flaw, a fault, a broken part of the program. So now let's take one step up to that yellow card that says a vulnerability. Now imagine that somebody who was aware of that bug, because their printer wouldn't print, went digging a little bit further and found that actually, with the right sort of shenanigans, they could put JavaScript in a web page that would trigger the printing, and it wouldn't go through that, is your printer online and do you want to proceed? It would skip that dialogue, and so somebody could lure you to a web page, put some stuff on the web page, and then cause it to print out on your printer. Now, that would be a bug because remember, you're supposed to get that dialogue that says, yes, I do wish to proceed, but stuff comes out on your printer. Now, that could be inappropriate material. It might be stuff you don't want exposed on a remote printer. So if somebody figured out how to take that, you are supposed to have control. The user experience is press the button and figured out a way to cause the printer to print using JavaScript in an untrusted web page. You would probably admit that that would be not just a bug, but a vulnerability. And by vulnerability or vuln, what we mean is a fault in the software that essentially affects security, your cyber security, in a negative way. Something that doesn't just cause you to get annoyed because you can't print, but could actually reduce security by making the software behave in an unexpected or dangerous way, in particular by not requiring permission or authority to do something that it's supposed to do. Now at this point, so loosely speaking, all vulnerabilities are bugs, but fortunately not all bugs are really vulnerabilities. So let's take a step up from there. Let's take that vulnerability towards something that could get to to a misfeature that will lead us on to exploits. And very simply, an exploit is a vulnerability that somebody has figured out how to abuse actively and practically in real life. So here's another level of vulnerability in that printer. Imagine that the person who's figured, hey, I can now print stuff at will without you getting the choice to head it off at the pass by going, no, I didn't want to print that. Let's say that they've also realized that as well as setting a print job going without asking you, they could change the print job to write it to a temporary file and then print it without asking you. So then they could create a print job that consisted, for example, of executable code, for example, or a script, a shell script, or a command line invocation that then gets saved to a temporary file somewhere on your computer. Now doesn't sound like a terribly dangerous vulnerability, but of course it could be, because it means that what that person at the other end has got is a way of sending content to your browser, printing it, bypassing the "are you sure," and instead of printing it, they're actually saving or creating a file on the disk that remote websites aren't supposed to be able to do. So that would be an example of a step up in vulnerability. And that kind of vulnerability, as mild as it sounds, is definitely exploitable, because it could be combined with an attack later that references that temporary file that was created and uses it to run externally from the browser as some kind of malicious script or malware. So that kind of vulnerability, doesn't sound super serious, but it is very much worse than just not being able to print because of a bug. Let's take another step up in exploitable vulnerabilities. Imagine that the person at the other end can not only bypass the "are you sure you want to print this" dialog and automatically select and print to a temporary file. Imagine that they could say print to a file and they get to choose exactly the file name they want anywhere on your computer. So now they can send you to a web page that looks entirely innocent, and in the background it might be quietly and silently printing, not via your printer, but to a file. For example, on Linux it might write to /etc/hosts, which is a file that basically redirects individual domain names to specific IP numbers, so it can basically change your web traffic so that traffic that you would expect to go, say, to example.com, which is in a particular place that you're supposed to look up and find on the internet, actually goes to a completely different site owned by the crooks. And then they could use your browser to visit the site that they've just redirected via the host file, and basically that would be a very serious, very exploitable vulnerability indeed. Even worse, for example, imagine on Windows that they could print, and air quotes there, note, to a file called c:/windows/system32/notepad.exe. Then they could actually replace the notepad file on your computer, and the next time you ran it, or the next time you double-clicked a text file to see what was inside it, and the operating system ran notepad, the crooks would have left behind some malware that they could run later. And that would be a very exploitable and dangerous vulnerability indeed. So the bug is the fault. The vulnerability is a fault that not only causes you hassle or annoyance, but actually potentially reduces security. And an exploit is when somebody figures out a way to take a vulnerability and actively and practicably abuse it in real life. So the last thing we have to mention, of course, is that dreaded term 0 day. And basically, as like I said, all vulnerabilities are bugs. Fortunately, not all bugs are vulnerabilities. All exploits rely on vulnerabilities. Fortunately, not all vulnerabilities can be exploited. And very fortunately, not all exploits are 0 days. Some exploits are figured out by the good guys in advance, and the term 0 day basically means there were 0 days during which even the most switched on system administrator or user in the world, the most proactive patcher, could have patched in advance. Simply put, the crooks got there first. My understanding is that this term comes from the old days of game piracy, where in the last millennium, when games companies, there were no cloud games, there's no cloud, there's no internet. You bought your games on floppies or CDs. And the games companies went to great lengths to put copy protection and rip-off protection in there so that their games couldn't be stolen. and the game pirates, game crackers, would have a competition. Let's see who can make that game available for free to bypass the need to pay or license it as quickly as possible. And if you could do it within 4 days after the game came out, that was great. 3 days, even better. 2 days, wow, you're a super hacker. And if you came out with the hack, the crack, on the same day as the game, then that was known as a 0 day, because it meant there was 0 days that the game company got a clear run at actually selling the intellectual property they'd just published, because people could start stealing it immediately. And that name was borrowed for patches, and by 0 day it simply means the crooks got there first. No matter how quick at patching you were, by the time you applied the patch, there's a chance that the crooks could have abused it already. So there was no point at which you were ahead. Technically, I suppose if it was found a week before the patch came out, it would be a -7 day, but we don't use that term. We just call it a 0 day to mean it's something that's already exploitable, and the exploit is not just known to the good guys. We know that it's also known to the bad guys. So the bottom line of all of this, folks, very simply, having done the jargon busting, and I hope explained it in plain English, is simply to remind you why patches are important and why we so regularly say something that sounds, unfortunately these days, like a truism or a cliche, and truisms are called truisms because they're true, why we so often say patch early, patch often. Because remember that although not all bugs are vulnerabilities, many of them are. And although many vulnerabilities never actually become exploited or exploitable, or nobody figures it out, you have to assume that given enough time, given enough effort, somebody might well figure out how to turn a vulnerability into something that's not just, oh, well, I can crash your browser occasionally, but I can crash your browser at will and take it over. In other words, you have to assume that anything that is called a vulnerability gets that name because it does indeed make your system, your operating system, your browser, or any application vulnerable. And because it's vulnerable, with enough time and effort, with enough will, with enough good luck, the crooks might be able to find out how to exploit it. And remember, if they exploit it before the good guys come out with a patch that can fix the problem, then we call it a 0 day, because it means the risk is actually known to be present. So that's why we say patch early, patch often. We don't just say it because it sounds nice and it rhymes. Does it rhyme? Yeah, but it sounds all rhythmic. We say it because if there's a way that you can either get ahead of the crooks, or if they're ahead, catch up to them in terms of an exploitable vulnerability, why wouldn't you do so? So thanks for listening, everybody. Please patch early, patch often. And until next week, stay secure.